So students, our today's topic is determination of zinc content of deodorants and antiperspirants. In the previous lecture, we had studied the determination of aluminum content of deodorants and antiperspirants. So the zinc content of deodorants and antiperspirants can be determined by using atomic absorption spectroscopy in the same way as that of aluminum. So there is little bit difference here. So the difference is that in the case of aluminum, we used aluminum standard for making or recording absorbances, whereas in this case we will use zinc standard. So our requirement will be little bit of different and rest of the things will remain same. So what are the requirements for estimation of zinc content of deodorants and antiperspirant? First is given sample of deodorant or antiperspirant. Then we require aqua regia, which I had already told you that aqua regia is a mixture of 1:3 concentrated nitric acid and hydrochloric acid, and in this case we can also use concentrated HCl, but that will depend on the type of reagent we are using. And next we need to use zinc metal. In case of aluminum we used aluminum metal, so in this case we can use zinc metal, or we can use zinc oxide also to prepare standard solution of zinc. And zinc oxide is having molecular weight 81 grams per mole, and zinc nitrate we can also use zinc nitrate whose molecular weight is 189 grams per mole. And if zinc nitrate is not available, then we can use zinc nitrate hexahydrate whose molecular weight is 297 grams. So we can use any of the four to prepare standard solution of the zinc. Now I will tell you one by one that how will you prepare standard solution of zinc by using each four of them, that is either by using zinc metal or by using zinc oxide or by using zinc nitrate or zinc nitrate hexahydrate, and we need distilled water. So first step in the determination of or estimation of zinc content of deodorants and antiperspirants is preparation of standard solution of zinc. So as I had already told you that if we use 1 milligrams of a solute in 1 liter, say 1000 ml, then its concentration is equal to 1 ppm. So and if I use 1000 milligrams per liter, then its concentration would be equal to 1000 ppm. So now we need to prepare 1000 ppm solution of zinc, means the solution in which concentration of zinc is 1000 ppm. Please note here that I am talking about the concentration of zinc, not that of the zinc salt like zinc nitrate. So if I want to prepare a solution of zinc whose concentration or in which concentration of zinc is 1000 ppm, so I can prepare that by using all these four that I mentioned earlier. So first of all I am starting with by using zinc metal. So if we want to prepare 1000 ppm solution of zinc by using zinc metal, then we need to dissolve 1 gram of zinc metal in 30 ml of 5 molar hydrochloric acid. As I told you earlier that we can use hydrochloric acid. So if we are using zinc metal, then we can dissolve that in hydrochloric acid. And if we dilute this to 1 liter in a volumetric flask with distilled water, then what I did, I dissolved 1 gram of zinc metal in 1 liter. So what is the meaning of 1 gram of zinc metal? 1 gram of zinc metal mean 1000 milligram. So if I am dissolving 1000 milligram in 1 liter, then its concentration would be 1000 ppm. So this solution is having concentration equal to 1000 ppm of zinc. Now if I wish to prepare solution of zinc of 1000 ppm concentration by using zinc oxide whose molecular weight is 81 grams per mole, then in order to calculate the weight of zinc oxide to prepare solution of zinc of concentration 1000 ppm, we need to apply this equivalence, because if I take zinc oxide equal to 81 grams mean 1 mole, then how many mole how much amount of zinc it will contain? As atomic weight of zinc is 65, so I can say that 81 grams of zinc oxide contain 65 grams of zinc. So I can apply equivalence that 65 grams of zinc is equal to or is equivalent to 81 grams of zinc. So if I can say that 1 gram of zinc would be equal to how much grams? 81 divided by 65, and this comes out to be equal to 1.246 grams of zinc oxide. Now what is the meaning of this? The meaning of this is that if I dissolve 1.246 grams of zinc oxide in 1 liter, then I can say that it will be having 1 gram of zinc. So I mean to say here is that if I am dissolving 1.2456 grams of zinc, then it will contain zinc oxide, then it will contain zinc equal to 1 gram or say 1000 milligram. And if I dissolve that in 1 liter, then the concentration of this solution would automatically be equal to 1000 ppm of zinc. So if I dissolve 1.246 grams of zinc oxide in 5 ml of deionized water followed by 25 ml of 5 molar hydrochloric acid and dilute this solution to 1 liter in a volumetric flask so as to make the total volume equal to 1000 ml with distilled water, then the concentration of zinc in this solution will also be equal to 1000 ppm. So this is how you can prepare zinc oxide solution of 1000 ppm concentration. Next is, if I want to prepare 1000 ppm solution of zinc by using zinc nitrate. Now zinc nitrate is having formula ZnNO3 twice and its molecular weight is 189 grams per mole. So you can similarly calculate from zinc nitrate, as zinc nitrate is having molecular weight equal to 189 gram. It means 189 grams of zinc nitrate is having zinc equal to 65 grams. So I can apply equivalence that 65 grams of zinc is equivalent to 189 grams of zinc nitrate. So 1 gram of zinc will be equal to 189 by 65 grams of zinc nitrate, and this comes out to be equal to 2.907 grams of zinc nitrate. So if I dissolve 2.907 grams of zinc nitrate, say anhydrous, because it is not having any water, so it is anhydrous zinc nitrate in 1 liter of distilled water, then it will be having 1 gram of zinc or say 1000 milligram. So it means if I dissolving 2.907 grams of zinc nitrate, it is having 1 gram or 1000 milligram of zinc. So our concentration of this solution will be 1000 ppm of zinc. Now you can also prepare this by using zinc nitrate hexahydrate whose molecular weight is 297 grams. So by using similar considerations, the 1 gram of zinc comes out to be equal to 4.569 grams of zinc nitrate hexahydrate. So by dissolving 4.569 grams of zinc nitrate hexahydrate in 1 liter of distilled water, we will get a solution whose concentration of zinc will also be equal to 1000 ppm. So by any of the four you can prepare standard zinc solution. Next is preparation of solutions of different concentrations of zinc, like say 25 ppm, 50 ppm, 75 ppm, 1000 ppm. So we need to prepare these different solutions of zinc which will be having different concentration of zinc. What is the purpose of using them? Because we need to plot a graph, so we need different concentrations. We will prepare them and will record their absorbance at lambda max value of zinc. Now next is preparation of sample solution of deodorant and antiperspirant. This is similar to what or how we prepared in case of aluminium. And to recapitulate that, we took the deodorant or antiperspirant sample and dissolved that in aqua regia and followed by addition of water, and then we had heated that on a steam bath for 15 to 20 minutes with stirring, and then allowed the solution to cool and dilute to 100 ml with distilled water in a 100 measuring flask. So this is our stock solution of deodorant of volume 100 ml. Now this will be having zinc. Now next step will be recording the absorbance or taking the absorbance reading. So as in case of aluminium, we used the wavelength 30, exact value was 309 nanometer. So in case of zinc, we need to fix the wavelength of the instrument at 213.9 nanometer, say equal to 214 nanometer. Now then after fixing the wavelength of the instrument at 214 nanometer, we will measure or record the absorbances of different zinc standard solutions of concentration 25 ppm, 50 ppm, 75 ppm and 100 ppm. Then we can record them in the table. In first column you can write concentrations and in the second column you can write absorbances. So when you are having absorbances of all these concentrations, then you need to measure the absorbance of prepared stock solution of deodorant or antiperspirant. After recording the absorbances of all these, what you need to plot a graph between the absorbance and concentration of zinc in ppm. So you can plot that by taking the absorbance along y-axis and concentration of zinc in along x-axis. So you will get this sort of graph. So in this, along the y-axis absorbance is there, which I have marked in green rectangle, and along the x-axis in orange rectangle concentration is there. You can record that in what unit you prepared the concentrations. I mean to say concentration you can express in any unit that you are using, but solution should be dilute. So you can see at the top of this picture I have written absorbance at 214 nanometer. Now what is the meaning of this? The meaning of this is that when you measure the absorbances of 25 ppm solution of zinc, 50 ppm, 75 ppm and 100 ppm, you recorded their absorbance at 214 nanometer and you got some values. So you plotted a graph and you will get different points. When you will connect these points, you will get a straight line. Now you are having unknown concentration as is marked in orange oval. This is similar to aluminium. So when you will extrapolate this onto the x-axis, this line will cut at the x-axis at some point. The point at which extrapolated line will cut on the x-axis will give you the concentration corresponding to that in the deodorant. So this is how you can determine the concentration of zinc in the given sample. And this is the text which I already made you clear, so I am not going to read it. This is what I explained you by using the picture. So this is all about the determination of the zinc content of the deodorants and antiperspirants by using atomic absorption spectroscopy. Thank you very much.